In this video, we're going to explore a vertical motion application problem where we have a rocket being launched through the air with an initial velocity and initial height. We're going to answer these 4 questions, and we're going to do it by hand, and then we'll use the Inspire and the Desmos calculators in order to check all of our answers. So the first piece of information we need to figure out is the number of seconds it'll take for the rocket to land on the ground. I'm going to start by creating an equation that would represent that. So we're going to use the h of t formula to the right, and the height of the rocket needs to be 0. So I'm going to start off with 0 equals, and that's because when that rocket hits the ground, it's the height of 0. So I'm going to follow it with the negative 16 t squared plus the initial velocity, which is 108 feet per second, times t, plus 15, because that's the original height of the rocket when it's launched. It's on that 15-foot platform. So now to solve this, sometimes you could do factoring. You could plug it into the calculator to graph it and find the key features, but we're going to find the answer by hand. So to do that, we're going to use the quadratic formula over here on the right side. I'm going to start by setting it up, and now I'm going to plug in my a, b, and c values. So you can see that the a value right here is in front of the x squared, which is negative 16. I'm going to plug it in here and there. Then I'm going to plug in my b value, which is in front of that t, right? So that's going to go there and there. And I'm going to plug in my c value, which is the constant, which is 15, and it's going to go right there. So now I'm going to simplify. I've got x equals in front, being negative 108 plus or minus, and then underneath the radical, I'll plug that stuff into the calculator. I'm going to get 12,624, and that's all divided by negative 32. And now I can plug this all into the calculator. It'll make things a little bit easier. I'm going to do a positive version and then a negative version because we have that plus or minus. So to start, I'm going to type in the plus version. I'm going to add in a calculator. I'm going to start by adding in a fraction template. And then I could type in what we have, a negative 108. And then we're going to start by adding the square root of that big number. Oops. Go back in there, which was 12,624, and then all divided by negative 32. Hit enter, and there's the amount of seconds that we have. It would be negative 0.136, which doesn't make sense, right? We can't have negative time, so that's not going to be the answer we're going to go with. So I'm going to highlight all this, copy it, go to edit, copy, and then down here I'm going to go to edit and paste it. And I'm going to change the addition to subtraction. This will be the other version, which gives us 6.886 seconds, and that's the one that we're going to go with. Okay, the next thing that we want to figure out is part B, which is the number of seconds it'll take for that rocket to reach a height of 175 feet. So I'm going to go through and do the same process, except that we'll see up here, 0 is the height. Now, instead of having a 0 height, we're going to do a height of 175 feet. So I'm going to rewrite the equation again, but I'm going to set it equal to a height of 175 feet. And before we apply this to the quadratic formula, we need to get the equation equal to 0. So let's get rid of that 175 by subtracting it from not only the left side, but we got to keep things balanced. We got to subtract it from the right side. And we're left with 0 equals the negative 16t squared plus 108t minus 160 now. So I'm going to go through and quickly apply the entire quadratic formula again, and that'll come up with our final 2 answers. Now in this situation, we have 2 answers that are positive, so they both make sense in a sense. You don't have any negative time, but this one is going to be the one that we want to go with, because the question, if you scroll back over here, it says how many seconds will it take for the rocket to reach a height of 175 feet? So how many seconds will it take for it to get there? Well, when it goes up, right, I'm going to kind of sketch this up. It goes up, it's going to first hit 175 feet at that first time. right? 2.196 seconds. But then it'll also hit 175 feet again at 4.554, because once it goes up, it's going to have to come back down. So as a little bit more time goes through, you're going to be hitting that 175 feet again at 4.5 seconds. So it'll hit it here, and then it'll hit it here. That height would be 175. Okay, and let's do part C now. It says, how many seconds will it take for the rocket to reach its maximum height? And that one we're going to almost do with part D. They sort of go together. So we need to figure out that maximum height. And I'm going to bring back my equation now. So here it is, h of t equals. And I'm going to bring in the formula for the axis of symmetry. That's x equals a negative b over 2a. I'm going to figure out my, well, I do know my b value is 108. And then I got my, a value is negative 16. So I'm going to plug in those values into the formula. And when you evaluate that in a calculator, you'll get 3.375. And that's going to be time, still, seconds. So at 3.375 seconds, it's going to be right in the middle of our graph. So imagine if this is sketched, right? And we have our parabola going up, and then it's coming back down. We know that directly right here in the middle, this is going to have an x value of 3.375, because that's the axis of symmetry. That's what cuts that parabola in half. And that would be then the time right here in the middle, where that rocket gets to the maximum value. So if we want to think of this as a point, that would be 3.375 for the x value. And then we don't know what that y value is, okay? Which then would bring me to the last part, question D. Question D is asking for the rocket's maximum height. So back down here, we know that the maximum height happens at 3.375 seconds. So we could plug that back into our equation here. We'll evaluate this for 3.375 seconds, and that'll kick out our time. So all we're doing is substituting for the t variable our time, and after we evaluate, we know that that's going to be 197.25, which represents feet. So then I could actually go ahead and erase this part up here in the in my little sketch. So that's going to be the height right here of the rocket at its maximum, and that happens at 3.375 seconds. Now that we have all of our answers by hand, let's go into the graphing calculators and check all of our answers.